Now you might remember from a few videos ago I was using this aircraft gauge, which is unusual. It's got two temperature scales, so it's going to have one thermocouple on one side of the engine and one on the other. And if you remember from before, basically I've kept the gauges, but there's a little computer on the back, and the computer reads the temperature sensors. And then there's a tiny little stepper motor, electronic motor, which moves in tiny steps with the needle on each one. So it looks old, but actually it's modern. So there's a problem with it. If you look closely, you can see that the spaces between for each 10 degrees, the change in angle that the pointer has to move is pretty equal up to 100. Above 100, if you look, they get narrower and narrower and tighter. So I can't just have the software say, for every 10 degrees temperature increase, move the pointer through like that angle, so many little steps of the stepper motor. I can up to about here, and then I've got to custom change it. So basically I made I won't go into the details, but I'll just show you the kind of time you spend doing stuff. So it's going through the test routine. Right, and they'll go down to 0. Now each time I press this little temporary button, it thinks the temperature has gone up by 10 degrees. So I'm going to press it. Right, so that's temperature of 0 degrees, that's good. Next time I press it, it's going to be 10 degrees. Right, now you can see they've both moved to about the 10 degree mark, so I'm pretty pleased with that. Press it again. Right, 20. 30, 40, so far so good, 50, I'm doing alright. So I spent a whole morning on this. 60, 70, 80, right, 90, 100. So that's pretty dead on, so up to 100 we're alright. Now you could argue that with a flat head, you're not going to go above 100. You actually want it to run in the 90s, I think. What's 161.70 Fahrenheit? I'll have to look it up. It's about in the 80s, 90s degrees. Anyway, then it gets tricky because the intervals get smaller. So let's go to 110. Right, I've spent all morning getting this right. So it's gone out of focus. There we are. Again. Right, 120, close. 130, 140, or is that 150? Hang on, that's 150. So that's pretty spot on. But I'd say that took a whole load of jiggering of the software to make it do that. So now that should read reasonably accurately, I hope. And all I've got to do is power it through the USB lead and it'll power up. I'm just going to use a mobile phone power bank to power all the instruments. I could have one computer running all the instruments, but if there's a fault, if there's something wrong, I want the other instruments to carry on working. So although it's more complicated in a way, each instrument's self-contained, it's got its own tiny little computer in the back. So that's sorted, and then there's my tachometer to think about next. So the next thing to look at is the tachometer, and again it's got the same type of little computer in the back. Right, so it just tests itself. There we are. Now, what have I got attached to this? This is called a Hall sensor, and basically every time a magnet gets close to it, tiny magnet, it acts as a switch, so it sends out a pulse to the computer. So if I look at the screen, it's got measured RPM. At the moment it's nil. But if I start doing this, right, you can see now it's 59, 300. Oh, it's a bit. Hang on. There we are, 179. And basically it's moving around, but not by much because I can't turn it fast enough. Anyway, you get the idea. So if I attach a magnet to a rotating part of the engine, then I mount this really close to it, then this should work. It might need a bit more tweaking, but it should work. So I've got an RPM meter as well. Right, something a bit different now. I've got this old voltmeter, and it looks the part in terms of being old, but it's completely broken. I have taken it all apart and it's still broken. So I've got this one from good old eBay, taken off the cover. It just comes off, and you can see the mechanism is in a similar design. It's all at the bottom, and then this top part with the display on is all just plastic. So my thoughts are I could trim all this down and cram it in here, or be better, I'd like to keep the display. I could trim this down, put it in there, take this display which is on a piece of metal and just glue it in front of that one. I don't know yet, but basically I've got to get this into that, so it looks period correct. So yeah, if you take that apart, I've now got this, and you can see if I undo these two screws, this plate comes out. I could glue it on there and then just start trimming plastic away till that slides into there. That might work. That's free now, and that will fit there. Whoop. Anyway, you get the idea, it will fit there. And then if I draw around here and trim all that plastic away, I have to shorten the pointer a tiny bit. It should go back into this enclosure. The back side of it will need reforming with a 3D print of some sort, but that's all. Interestingly, you'll notice that when I put the old dial on, the curvature of this exactly matches this part here of the plastic. The width of this is exactly the same as in the old one, this area, and the holes, although they're in different place in the side to side plane, in the up down plane they're in the same plane as well. So it's almost like there's an industry standard going on here that goes back many years, and no one's ever bothered to change it. Anyway, so I'm going to trim the plastic away now until basically, yeah, look, it's pretty much the same diameter, this piece, that circle. So I'm going to trim it down to here and then screw that on to these two screw points, and yeah, in theory it might all fit in. So yeah, that doesn't look too bad, does it? That's pretty good. Of course, I've just got to glue the glass in, clean this glass up and glue that in first, and then make some sort of protective case for the back, but I'm pretty pleased with that. So now I've 3D printed this part, which will glue there like that, and then the whole lot will go into the back of this up until that lip there, and if I measured everything right, that should leave just enough room here for everything to move without hitting the glass, and the glass has been super glued in now, so it's time to put it together. Right there. Needle moves freely.